like to introduce Sabine Rommevaux, our next speaker. Sabine is a senior researcher at the CNRS. Her main research focuses on the history of mathematics, the theory of proportions, and algebra. And she has worked on a lot of diverse figures, including Euclid, Bradwardine, Orem, Blasius of Parma, and perhaps especially Christopher Clavius. Her paper today is titled A Science of Mathematicalia in the Questiones Mathematicae of Radulphus Brito. Sabine, the floor is yours.
Thank you very much for the presentation as the invitation. So what I am going to present today is a work in progress, and I'm sorry for that, because I'm not sure at this point that I understand all aspects of Brito's reasoning. It will be necessary for me to look at other texts than the Questiones Mathematicae I will present today, but I have not had the time for that. And so any comments you have will be helpful. And I would like also apologize for my very, very bad English, so I hope you can understand me. Oh, it's impossible for me to, okay, so good. Okay. So Raoul Le Breton, or Radulphus Brito, was a master of arts in Paris around 1290. And after studying theology in 1299, he became a doctor of theology in 1313 or 14, and he died in 1320 or 1021. Brito wrote the Questiones Mathematicae, as Olga Weyers calls them, at the very end of the 13th century. These Questiones can be found in 2 manuscripts in Paris and in Brussels, and I am working on a critical edition of these Questiones. In the prologue, Brito sets out the division of the sciences. Mathematics is presented as the science of beings, abstract from the sensibles, by the intellect, beings which are, however, related to the sensible substances in their being, in esse. The first 6 questions are devoted to mathematics in general. Questions 7 to 10 deal with the status of the sciences of the quadrivium, namely arithmetic, geometry, music, and astronomy. Questions 11 to 19 deal with the object of arithmetic. In question 20, Brito asks about the divisibility of quantity. Before devoting questions 21 to 13.4 to the objects of geometry. Question 25 to 35, sorry, to 13.9 are about compute, and the treatise ends with 4 questions on music. So I will present today the questions 4, 5, and 6, in which Brito circumscribes the domain covered by mathematics, in particular, whether it can concern substance and qualities. Before considering question 4, in which Brito asks whether there is indeed a science of mathematical entities, we must recall how he characterizes them. His position, to which he devotes the first 3 questions, is that mathematical entities joined to sensible qualities according to their being, in esse, can be abstract from them, and they can be apprehended by the intellect. It's Aristotle's position. Moreover, mathematical entities are prior to sensible qualities in generation and knowledge, even if they exist at the same time. Finally, mathematical entities differ from other forms in that they do not determine sensible qualities in the matter they affect. They are suitable for any matter, whatever its deposition, hot or cold, white or black, etc. They can therefore be apprehended without the sensibles to which they are attached. And Brito points out that mathematical entities are abstract from sensible qualities because of the very nature of these entities, even in the absence of an intellect to apprehend them. And it is this point we have to understand. The absence of an intellect to apprehend the mathematical entities. The Quenon arguments that open question 4, in which Brito asks whether there is a science of mathematical entities, are interesting in that they allow us to list the conditions for having a science. First, every science must proceed from a cause. Omnes scientia est per causam, whether it is final, material, formal, or efficient. Second, every science aims of some good. Omnis scientia est aliquoius boni operatrix. There is no science of what is corruptible. There is no science of accidents. Every science has intelligibles as its objects, and these intelligibles must be proportionate to the intellect. Everything intelligible is sensible. Every science is a true and certain knowledge of a thing, and there must be similarity between the thing and the intelligible. It is doubtful that mathematical entities meet all these conditions. Indeed, because mathematical entities are anchored in sensible substances, it is possible to argue that they are corruptible like natural things, and it is doubtful whether they are intelligible. But on the other hand, since mathematics deals with these entities as abstracts, it is doubtful that it can be a true science of them, since any true science must deal with natural things. Brito argues that there is a science of mathematical entities, and this science is the most assured and certain, firmissima and certissima. So he has to prove that Mathematicalia are intelligible entities, and he explains also that their properties can be demonstrated from principles. To prove that they are intelligible entities, Brito begins by pointing out that mathematical entities exist in re, outside the soul, and even if there is no intellect to apprehend them. For example, the number 4, the line or the triangle, exist in the natural things, even if they are not apprehended by any intellect. It may then be doubted whether they are intelligible at all. But Brito adds that mathematical entities are actual beings related with sensible entities, and they affect our senses by means of these sensible substances. He then qualifies them as sensitive entities, or at least remarks that they vary in the way they affect our senses. In the answers to the Quenon arguments of the first question, in which Brito shows that Mathematicalia can be abstracted from the sensible entities, he explains that Mathematicalia, such as number and magnitude, are not sensible per se et primo, but can be considered as sensibles because they are related to something sensible. the sensible nature of the thing to which the mathematical entity is related makes it apprehensible by our senses. Those mathematical entities are said to be sensible per allude, and they are intelligible. So let us go back to the question 4. The mathematical entities having thus affected our senses, they are intelligible, and after the intellect has apprehended them, it can then demonstrate their properties from the principles. Brito gives examples: the property of a number to be even or odd, prime or compound, of a given ratio to another number, etc. The property of a magnitude to be infinitely divisible, the fact that a triangle has 3 angles whose sum makes 2 right angles because the external angle is equal to the 2 internal angles. Brito adds that the principles are then the causes of the properties of these entities, and mathematics in the most certain and the most assured sciences, because its principles are the best known. In question 11, the same kind of argument is used to show that there is a mathematical science of number. Brito indeed explains that it is possible to have a mathematical science of something which is outside the soul, which has demonstrable affections or properties, which not determines of itself any sensible qualities. And Brito adds, which has parts into which it can be divided. Number is of its kind. It can be the object of mathematical science, the arithmetic. Here again, Brito points out the sensible encourage of number, which exists in natural things, even if no intellect is present to apprehend it. Thus, the number 3 is found in 3 stones or 3 oaks, and the fact that it is an odd number is a property of the number 3 that belongs to it, even if an intellect is needed to demonstrate it. Let us now return to the quantum arguments and see how Brito answers to the first one, which explains that every science must proceed from a cause, whether it is final, material, formal, or efficient. Concerning the final causes, Brito admits that mathematical entities do not have a final causes, conceived as a term of motion, and in mathematical demonstration, there is no syllogism with the final causes as a middle term. On the other hand, if we understood by end the term of the motion, then mathematics doesn't have one, but it still have a goal without specifying what it is. Brito's argument about material and formal causes helps us to better understand the status of mathematical entities and their relationship with the sensible. Brito explained that mathematical entities are forms, and their matter is a subject in which they are. And all these forms, when they are of the same kind, constitute the same abstract mathematical entity, the same form. This form not being conceived here as one of the members of the corporal matter form, but this form is the same thing as the mathematical entity sub ratione notori significativa, having a better known definition. Brito gives the example of whiteness, whose form is to be a color allowing the sight to discern, albedo is color disgregativus visus, the definition in metaphysics, in Aristotle's metaphysics. So the expression disgregativus visus means the same things as witness sub ratione notione. So let us try to give a mathematical example which is not in Brito's text. Any rectangular table, whatever its material, wood, stone, etc., contains the rectangle. So the rectangle is as many forms, each of these forms having a matter, the table in which each one is. But all these forms constitute a single mathematical entity, a single form, which is then the figure made up of four straight lines having 4 right angles. And this definition allows us to understand better what the rectangle is than the simple term rectangle. Therefore, there is a science of these forms, these mathematical entities, the intellect being able to demonstrate their properties for their own principle. Finally, Brito explained that we do have efficient causes in mathematics, efficient being understood here as a principle of the being of something by per emanationem, and not by movement. For example, having 3 angles equal to 2 rights is caused by the principles of the triangle. Let us now turn to the question 5, in which Brito asks whether there is a mathematical science of substances. He explains that although the mathematician is interested in substance as subjectum of quantity, there is no mathematical science of substances considered for themselves as substances. This time, the argumentation is based on the property of mathematical entities not to determine sensible qualities in the matter in which they are. The fact that a table is rectangular does not imply that it is of this degree of heat, of that degree of humidity. Then Brito notes that all sensible substances, whether they are simple, such as substantial forms of and matter, or whether they are aggregates of matter and form, all these substances determine a particular combination of sensible qualities. For example, in every man, there is a particular combination of sensible qualities, so that the form man could not subsist in a matter not having such a combination. Therefore, these substances cannot be objects of the mathematical science. To those who would like there to be a mathematical science of substance in general, in communi, this substance being considered by abstraction, Brito replies that this substance, considered as substance, and thus separated from his accidents, is treated by the by the metaphysicians and not by the mathematicians. And in the answers to the quantum arguments, Brito makes it clear that if a substance cannot be abstracted from its accident, this abstraction is not identical with a mathematical abstraction. In the mathematical abstraction, it is necessary that what is abstracted by accidentally related in being with something that is posterior to it and which it does not determine. In contrast, even if the substance can be abstract from its accidents, it determines some sensible qualities. Since qualities can, like mathematical entities, be considered by abstraction, independently of the matter to which they belong, Brito finally asks whether we can have a mathematical science of them qualities. It's question 6. He deals here only with accidental qualities, not with essential quality or substantial form. Brito answers that there is no mathematical science of the qualities of the first 3 species: first species, dispositions and habits; second species, natural capabilities and incapabilities; third species, affections and affective qualities. But there is a mathematical science of the qualities of the 4th species, shapes, not because they would be the subject of this science, but because they are properties of the mathematical objects, and that a science is as much about subjects as about their properties. To prove his opinion, Brito again relies on the characterizations of mathematical entities that he has given. They can be, by nature, abstracted from sensible qualities, and they do not determine any quality, either by themselves per se, or because of the subject to which they are related, ratione subjecti immediati. However, all the qualities of the first 3 types determine sensible qualities, either as effects or as disposition and properties of subject. So to summarize, as I understand at this point, mathematical entities are, on the one hand, linked with the sensible. On the other hand, they are abstraibilia. They have the capacity to be abstracted, and this capacity exists even in the absence of an intellect. To put it another way, in the rectangles found in natural things, we have the same mathematical entity, rectangle, a form common to all these rectangles, which exist even if there is no intellect to abstract it from the observation of rectangular tables, for example. Mathematical science has as its objects these mathematical entities, abstracted, then apprehended by an intellect that demonstrates their properties. The sensitive anchoring of mathematical entities, on which Brito insists, allows him to ensure that the science of mathematical entities is a true science. Indeed, all true science must deal with real things. Now, if mathematical entities are not sensible, if mathematical science does not study these entities insofar as they are in matter, but abstracted, nevertheless, mathematical entities are sensible per allude or per accident. This is enough for Brito to ensure that we have a true science of them. Moreover, the entity as a characteristic, the mathematical entity as a characteristic of not determining any particular combination of sensible qualities in the subject to which it is attached. This property allows Brito to demonstrate that there is no mathematical science of substances considered as substances, nor of all of the qualities of the first 3 species. finally, it is interesting to compare Brito's argument with that found in other questions of the same kind produced in Paris at the same time. So I have to do that for my article. But I have compared Brito's argument with one we found in the questions dealing with the same subject by various Parisian masters copied in the manuscript of Munich, edited by Del Anna. Referring to Aristotle's authority in Book 6 of the Metaphysics, Sebastianus de Aragonia explains that there is a science of mathematical entities because there are intelligible beings with properties, principles, and parts. However, immediately rise a doubt. It is not possible to have a science of an imaginary being, opinabile, but mathematical entities are imaginary entities, just like mathematical propositions, as Averroes says in his commentary of Book 3 of the Physics. Sebastianus answers that something is imaginary in two ways. Either it is a chimera to which nothing corresponds in reality, and it is not the subject of science, or something corresponds to it in reality, as in the case for mathematical entities, and we do have a science of them. Here again, the sensitive anchoring of the mathematical object ensures that we have a science of it. Sebastianus' argument is less sophisticated than Brito's. It seems to me that Brito's originality lies in the fact that he explains that mathematical entities are abstract entities, even in the absence of an intellect that can abstract them from the sensible. On this point, I have the impression that he differs from Aristotle, for whom mathematical entities exist from the moment an intellect has abstracted them from the sensible. Brito does not, however, make them separately existing forms, as Plato does. The form rectangle exists in each rectangular table and is common to all of them. Its definition and properties do not depend on the substance to which it is accidentally attached. So I finish here. I have no conclusion at this point. So for my article, I hope to have time to compare Brito's argument with other questions of the subject in Brito's works and in other authors. So thank you, and sorry for that chaos.
Thank you very much. Thank you.